Today we're going to be doing practice problems from Algebra 1, Module 1, Lesson 22, Solution Sets till Simultaneous Equations. Question 1. Estimate the solution to the system of equations whose graph is shown to the right. Okay. What I see here is I see an intersection. That's going to be where my solution is located on the graph. I see that it's not an exact point, and this is often the trouble with graphing systems, is that we can't always see the exact point. So I can estimate, however, that this does look like it's a little bit past 5 and a little bit under 1. Okay, both positive values. I can say that it looks like about maybe 5.5 and a little bit under 1, so maybe 0.8. Okay, we'll list that as an ordered pair. And that's my estimate. Question 2. Write the two equations for the system of equations and find the exact solution set to the system algebraically. All right, well, in order to do that, I'm going to have to go ahead and find some equations. And because this is a graph, my easiest way to go about it is in y equals mx plus b form. I'll go ahead and start with my positive line. Okay, my y-intercept is located right here. Okay, in fact, I'll go ahead and put a dot on it so you can clearly see it. My y-intercept is at -3. Okay, from there I'm going to need the slope. In order to put something in slope-intercept form, you need two pieces. You need the y-intercept, which I've already found, and you need the slope. In order to count slope, you would need 2 points. So I'm just going to go up my line until I cross a nice pretty point. So I'm going to use this. I'm going to use its y-intercept. And the reason why I had to point out a second point was to be able to find the slope. Okay, slope is going to be rise. So this is my rise over run. And that right there is my run. So I'm going to need to count both of those distances and put my rise over my run. Okay, I'm going to go ahead and put a text box here. Okay, it looks like I rise from -3 to 0, so I rise about 3. I run from the origin all the way to the 4, so I run 4. Okay, so my rise and my run is 3 over 4. This is a positive line, so my slope for this line is 3/4. I'm ready to go ahead and state what my equation is. My equation is y equals 3/4 x minus 3. Okay. Looking at my second line, my negative line, I'm going to go through the same procedure. I'm going to go ahead and take a dot and put it right here on my y-intercept, which is +6. I'm also going to go down, 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 down until I see another perfect point. I can choose any point on my line. The one that I chose to use was this one. From here, I'm going to point out my rise and my run. Okay, there's my rise from here to here. And this is my run from here to here. So I see it looks like I'm going up 2 over 2. So if I put my rise over my run, 2 over 2, I get a slope of -1. So my b up here is at 6, and my slope is at -1. Okay, so I'm ready to write that equation. Y equals -1x plus 6. Okay. I'm going to go ahead and move to another page to do my workout for solving the system algebraically. It can get pretty lengthy stepwise, especially whenever we're talking about non-whole number points. So I'm going to go ahead and pull to a nice clean page. This is the system that I came up with. Y equals -1x plus 6 equals 3/4 x minus 3. I'm going to go ahead and use the substitution method here to solve this. I'm going to take negative 1x plus 6, and I'm going to place it in place of the y, because if y equals this, I can put it into the y. That's any substitution problem that I have. Okay, so we're going to go ahead and pull negative 1x plus 6 equals 3/4 x minus 3. So now the equations are set equal to one another. I'm going to go ahead and rely on some equation solving skills. I'll go ahead and start by subtracting 6 from both sides just to move my whole numbers over. So when I have 6 minus 6, I can cancel those. And negative 3 minus 6 is going to make negative 9. So I'm going to get something like this. Negative 1x equals 3/4 x minus 9. Now I have to move my 3/4 x to the front. So I'll go ahead and subtract that from both sides. Okay, so I'll take 3/4 minus 3/4 on this side. And on this side, I've replaced negative 1 with negative 4/4. Okay, this will just make it easier for me when I'm dealing with the fractions to have them both in fraction format. So negative 4 over 4x minus 3/4 x is going to make negative 7 over 4. Okay, so now this is what we have simplified. Negative 7 over 4x equals negative 9. In order to undo the multiplication of the fraction, I'm going to have to multiply out by its reciprocal, or its flip-flop. So 7 over 4 flip-flopped was going to be 4 over 7. So I'm going to need to multiply both sides of my equation by negative 4 over 7. What happens on the left-hand side is that this is going to make 1. Okay? And then I have a negative times a negative is going to make a positive. And 9 times 4 is going to make 36. So we're going to have positive 36 over 7. And that's my x value. In order to find my y value, I'm going to have to go and plug my x value in. I would prefer not to plug it into the 3/4 equation just because fractions times fractions, right? Let's go ahead and stick with the negative 1x plus 6. So I'm going to use negative 1x plus 6, and I'm going to take my 36 over 7 and plug it in place of the x like this. So y is going to equal negative 1 times 36 over 7, which is just going to be negative 36 over 7, plus 6. Okay? So once I'm done and I've calculated all that out, I get positive 6 over 7. So my ordered pair is exactly 36 over 7, comma, 6 over 7. All right, one more question. Write a system of inequalities that represents the shaded region of the graph. Okay? Well, what I see is if I back it up a bit, this graph and this graph are exactly the same, except this graph has this shaded region. So let's go back to my system that I created for the lines. Y equals negative 1x plus 6 represented this line, and y equals 3/4 x minus 3 represented this line. I'm going to need a shaded region, which means I'm going to have to change my equal to signs to inequality signs. Okay? So, my first line is the 3/4 x minus 3. It looks like I'm going to have to shade above that line. So because I want to shade above that line, I'm going to have to use a greater than symbol. Okay, so y is, we're going to use the symbol greater than or equal to. Okay, not just greater than, because these are solid lines. These are not dashed lines. Dashed lines would have represented not the line, but just a shade above. Because it's greater than or equal to, it can equal my line. Okay, so I want greater than or equal to this line, which is 3/4 x minus 3. Okay, and then my next line comes right here, this negative 1x plus 6. It looks like I also want to go above that line. And because I'm going above that line, we're going to use the same symbol, greater than or equal to negative 1x plus 6. We would use the less than symbol whenever it was below the line, but the greater than symbol whenever it's above the line. These have been practice problems from Algebra 1, Module 1, Lesson 22, Solution Sets to Simultaneous Equations.